Okay, Matt, we're back talking about exponential notation. Now we're going to be talking about some of the exponent laws or the exponent rules. Just to let you know, they're really well summarized in here in the workbook. The notes are pretty well done, so feel free to take a look at these, especially for examples if what I say doesn't make sense. We're going to be talking about these ones here. This is in your workbook: the product rule, the quotient rule, and the power rule are the ones we're going to talk about in this video. And basically, I'm going to just talk about what's in these parts of the workbook. So if you already know that, then that's all we're talking about in this video. I think these can be pretty straightforward when you learn them in isolation, but when you start adding them together and having to do multiple steps at once, that's when it gets a little bit tricky. So you got to really understand the individual rules for eventually when we put it all together. So although it might seem simple at first, the practice is really going to be important to make sure we can apply these in more complicated situations. So we'll go back to our notes here. We'll talk about the product rule first. So the product rule is basically what happens when you multiply exponents, powers I should say. What happens when you multiply powers with the same base? Actually maybe I'll just go right back just to get my terminology here. We talked about this as being the base and the exponent. The whole thing put together is referred to as a power. So base and exponent are parts of the power. Okay, so the product rule is multiplying powers with the same base. For example, if we have 2 to the power of 3 times 2 to the power of 4. So there's, you could look at the expanded notation or the expanded form of these. We could see what 2 to the power of 3 means. It means, we could expand this out. Oh, I got some weird, hold on. I can move my mouse out of the way. So like 2 to the power of 3 is 2 times 2 times 2, right? Like that's that expanded out. And then we're going to multiply that by 2 to the power of 4. And I'm kind of getting out of range here, but that's 2 times 2 times 2 times 2. Still getting the hang of this pen. So like this here is that expanded out. So if you look at that, that's actually just 7 2's being multiplied together, which is the same thing as 2 to the power of 7. So it turns out that when you multiply powers with the same base, 2 to the 3 times 2 to the 4, for example, you don't actually have to do all this expanded form stuff every time. You could just add your exponents together. Do you see how we got 3 and 4 gave us 7? So this worked out to be 2 to the power of 3 plus 4, which equals 2 to the power of 7. So that's the product rule. It's a shortcut way of dealing with multiplying powers of the same base. If we go over to the homework, you got a whole question just to deal with that. Let me see if I can flip to that page. I'm going to guess. Nope, one off. So the first question, question 1, is just about multiplying powers that have the same base, and you have to add them together. Just one thing to watch out for. I think that some students will forget a few sneaky things. Like for example, a times a squared times a to the 3. There's no exponent here, but that doesn't mean it's 0. If you don't see an exponent, that means the exponent is actually 1. So watch out for that. So when you multiply these together, that gives you a to the power of 1 plus 2 plus 3, which is a to the power of 6. It's not a 0. And in fact, you will see examples where it is 0, a to the 0, for example. Then you just add 0 plus 1 plus 2. So that's fine. So that's the product rule. We're going to go to the next rule, the quotient rule. It's sort of the same thing, but for division. So we'll take a look at an example for that. If we have, say, 2 to the power of 5 divided by 2 to the power of 3. So, if we were to expand this out, that's the equivalent to 2 times 2 times 2. We'll just put out 5 2's along the top, and then we have 3 2's on the bottom. So what's going on here is that we're multiplying by 2's across, but also dividing as well. And if you multiply by 2 and then divide by 2, they kind of cancel each other out, right? Times something by 2, divide it by 2, you get to the same number. So effectively, the 2's on the bottom are canceling out the 2's on the top. So these are canceling each other out, these are canceling each other out, these are canceling each other out. So we're just left with 2 squared at the end, 2 to the power of 2. or 2 times 2. But do you notice a similar relationship? If we take a look at 5 and 3 and we got 2, you'll notice that it's a subtraction relationship. So 2 to the 5 divided by 2 to the 3, that's the same thing as, or a shortcut way to do that is just subtract the exponents. 5 minus 3, that gives you 2 to the power of 2. So that's the quotient rule. Quotient rule. You can just divide your powers with similar bases by subtracting the exponents. So we also have a whole question, if I can zoom out. Question 2 is just practicing that rule. You'll see there's a whole bunch of examples where we are doing this. There's a few tricky questions that I'd like you to watch out for. For example, F, x to the 7 divided by x to the 7. So that's going to be, you subtract your exponents, right? So it's going to be x to the 7 minus 7, which is x to the 0. And I'm actually not sure if this is in the answer key or not, but you wouldn't leave it as x to the power of 0 because anything to the power of 0 is 1. So that actually works out to be a 1. And we might talk about that coming up in a video with the negative exponents as well. So stay tuned for that. So, if you get anything to the power of 0, it's really just going to be 1. Can't think of anything too much to add. Watch out for adding and subtracting negative numbers. So for example, for G, we're going to be subtracting a negative 3, right? It's going to be negative 6 to the power of 4 minus negative 3. So that's the same thing as adding. So, that's going to be, actually going to increase. So if you want to use a calculator to do these, more power to you. You're always going to have a calculator in every assessment. Might as well do it with your homework as well if this is something that gets you down. So that would be a fantastic way to answer these questions. All right, that's number 2. There's a third question that's going to be about power rule. So we'll just go over the power rule. That's going to be talking about when you have a power raised to another power. So for example, if we have 2 to the 2 to the power of 3. I know, right? Like, what kind of craziness are we dealing with here? But this isn't actually that uncommon to see this happen in math. So we have 2 to the 2 to the power of 3. How can we simplify this? So basically, if we expand this out, that's like saying 2 times 2 to the power of 3, right? And to the power of 3 means repeated, 3 times. I'm just going to give myself a little more space here. So that's the equivalent of saying like 2 times 2 times 2 times 2. We're going to have 3 of these, times 2 times 2. So how many 2's are there altogether? Well, really, we have 6 2's. So we have 2 to the power of 6. And do you notice a relationship there? This time it's going to be multiplying. Whenever we have a power raised to another power, so 2 to the power of 2 to the power of 3, we actually can multiply our exponents together to simplify. That's going to be 2 to the power of 2 times 3, which equals 2 to the power of 6. So that's the power rule. Do you see where you can apply these things? We have ourselves sort of, different patterns where you have to see what's happening in the question and look for the correct rule to apply. So fortunately, we have a bunch of questions at the start, right? Number 2 is about quotient rule. Hey, number 3 is about power rule. So you're going to see examples where you're going to have to, solve these things. There's going to be, look out. Questions like this, we have to multiply 2 negative numbers together. I find that sometimes students who forget those rules will be overly punished for that. So don't forget to use a calculator if you want to make sure that that goes smoothly for you. Or brush up on how do you multiply and divide negative numbers, how do you add and subtract negative numbers. That can actually punish people pretty hard on this unit, so be careful about that. Just for the record, the answer for this question would be 3 to the power of negative 4 times negative 2, which is going to be 3 to the power of positive 8, because a negative times a negative is a positive. So there you go. There is a little bit more work to do for this question because it says express without negative exponents. So I'm going to do one last video. So I'm going to stop it here, but there's going to be one more video on negative exponents and also exponents that are power 1 and 0. Okay? Thanks so much, Math 10. We'll see you in a little bit.